Hello, and welcome to Splice Machine, the first and only operational AI data platform. My name is Ben, and I'm a machine learning engineer here at Splice. Today, I'll be walking you through our new ML Manager platform. ML Manager is an in-database data science workbench to support the complete machine learning lifecycle, from transactional updates to data wrangling and experimentation, and finally, real-time deployment. With an RDBMS at its core and integrated with MLflow, ML Manager supports industry-leading notebooks and provides libraries to a seamless path of model deployment. In this demo, I'll be walking you through a typical machine learning lifecycle on Splice Machine. To start, let's quickly go over what Zeppelin is. So Zeppelin is exactly what you're looking at right now. It's a web-based multi-purpose notebook that supports multiple languages, from Markdown to Python, Scala, R, SQL, and many more. It's tightly integrated into Splice Machine, allowing you to quickly ingest data from your Splice Machine database and begin data exploration and experimentation. As we work through this notebook, you'll notice that it is made up of a number of individual cells. This is a great way to organize your workflow, from data ingestion to exploration and feature engineering, and finally analysis. Cells with the same interpreter, defined at the top of each cell with a % sign, are able to communicate with each other, so variables made in one cell are accessible in the next. Now that you understand a little bit more about Zeppelin, let's talk about MLflow. MLflow is a great tool for tracking all of the steps of your data science workflow, from individual features to feature engineering to model hyperparameters and finally metrics. It tracks your movements every step of the way and makes model deployment simple and intuitive. So as you work through an individual model, you can save any parameters you'd like, and those parameters show up easily in the MLflow UI. So when you're going back through your models, you can compare those different models and the different feature engineering paths you've taken to determine the best model with 100% confidence. MLflow also allows you to store individual models themselves. So once you build a model in Spark and you want to, say, deploy that model to SageMaker, you can save that model to MLflow and easily grab it in our other UI and deploy it to SageMaker with ease. So now that you understand two of the important technologies behind these notebooks, let's get started. In this demo, we will be working on a common data science project, fraudulent transactions. Predicting fraudulent transactions is a very important problem for many businesses and requires numerous iterations and model tuning. ML Manager and its simple-to-use API makes this process easy. The first step in any workflow is connecting to your database. For this, we will use our Spark native data source called the Splice ML context. It allows us to communicate seamlessly with all of our data and import it into Spark data frames quickly without serialization. As you can see on the top left, we have set up the interpreter to be spark.pyspark. This tells Zeppelin that this cell will be writing Python code and potentially PySpark code. When a code requires a Spark execution, the code will be automatically sent to your Spark executors on your cluster and operated upon in parallel. To import our Splice ML context, we simply have a one-line code, splice equals Splice ML context, and we pass in our Spark session as an input parameter. Now that we have the Splice ML context defined, we can move on to creating our table. We do this by switching the interpreter in the top of the cell from spark.pyspark to Splice Machine, telling Zeppelin we will be writing our Splice SQL code. As you can see, this code looks just like the SQL you're familiar with, and it works the same way. Once a table is created, we can populate it by running our easy-to-use import command. This data is already stored in S3, so we will grab the data from there. The data we will be working with is data from Kaggle fraud competitions, and all of the columns have been anonymized to protect the identity of the transactions. Once we have our data, our table created and our data imported, we can easily run select statements with this and look at that data in an easy-to-see table in Zeppelin. An important part of data science is data visualization, and that becomes really easy with Zeppelin. When you make standard SQL queries in a Zeppelin notebook, you can look at your data with either standard tables or through a number of visualization tools built in. So we can see here that we have much more fraudulent data than non-fraudulent data, showing us that we're going to have to do a lot of undersampling in this data. We can also see that fraud transactions are on average more costly than non-fraudulent transactions, and we can see a number of bucketization techniques of these fraudulent transactions with really intuitive and interactive graphs. We can also look at one-to-one feature differences, for example, the time offset versus the column V1, and we can notice that at certain time spans there's a drastic change in our values. We can look at that over here with V2, or V3, 4, 5, and 6 against our time offset, and we can see that the similar value changes are consistent among these features. Before we import any of our data into a Spark data frame, let's quickly go over some basic MLflow concepts. MLflow breaks data science down into experiments and runs. Experiments are the overarching problem you are trying to solve, say fraud prediction, and runs are the individual trials within that experiment. Although this is a common way of using the two features of MLflow, the freedom of MLflow allows you to organize your work really in any way you and your team find most effective, and you're not bound to any specific design decisions. Creating your ML manager is easy, and what is returned from that call is the tracking URL of that manager. Each cluster is assigned a single manager, so even across multiple notebooks, you are working with the same one. This interconnectedness is really useful because you can organize your notebooks however you see fit and keep all of your experiments and runs together in one unified location, switching between experiments and runs as you see fit. Once our manager is created, we can create our first experiment with the manager.createExperiment command and pass in the name of that experiment in the input parameter. We can call that experiment anything we want as long as it's in a string format. When we set the active experiment, that tells ML Manager and MLflow that every run you create from this point forward is run under that specific experiment. You can change that dynamically throughout the process, keeping track of a number of different experiments at the same time. Once we have our manager and our experiment created, we can easily import the data from our Splice Machine database into a Spark data frame using the splice.df command. We rename the column class result to label for training, and we can show that data frame using the z.show command. Z is a built-in Zeppelin context that allows you to view your data frames really easily, and it works very intuitively with Spark data frames. We can then move to our port 5001 at a new URL, and we can see that our experiment was created. There's no runs yet in this experiment because we just created it, but as we create new runs, we'll be able to see them. In addition to MLflow and Spark, these Zeppelin notebooks and Splice ML Manager support all of your favorite libraries, like Pandas, Matplotlib, and NumPy. So in addition to the visualizations we were able to see with Zeppelin, we can also run standard visualizations that you may run with Matplotlib. So for example, here we can create a really simple heat correlation heat map between all of the different features in our table. And we can see that as these colors become darker, they are more correlated with one another. We see that red is obviously a one-to-one correlation as the feature maps to itself. Let's start our first run. Ben is a data science on this team and has finished his analysis and has a plan of action for this data. He plans to oversample the fraudulent data 2-to-1 and undersample the non-fraudulent data 1-to-1. Then he'll create a pipeline containing a vector assembler and a standard scaler, and to normalize his feature vector. Then he plans to use a neural network with a set of specific hyperparameters. Once this model is finished, he can analyze the results. This is a lot of information to him to remember and to relate to his team, and can be easily forgotten and misunderstood. But using the MLflow API, he can log every single step, from the oversampling rates to his feature vector, hyperparameters, and even metrics, including the time it took to train that model. Let's quickly look at the commands that he used to do each of these steps. So for the oversampling of the data, he can easily log the parameter that he's oversampling at a 2x rate, meaning that he's taking his fraud data and doubling the size of that table. When he then undersamples the non-fraud data, he can show and log that parameter as an undersample 1-to-1. So when he looks at MLflow, he remembers exactly what he did. In his pipeline, he can set the pre-processing parameter to a pipeline of a vector assembler and standard scaler. Now, as these two input parameters are strings, he can actually make these whatever he wants and has the freedom to really customize these parameters. He can also loop through every single feature of his feature calls and log each of those feature numbers and their names to MLflow. Once that's done, he can log all of the parameters, like the classifier and all of the hyperparameters he chose to use, and even the time it took as a metric. So the difference between logging a parameter and a metric is a parameter takes two strings, and a metric takes a string and an int value, or a double. So once he logs his metric of time, he can also go through all of the values in his evaluator and log the metrics of each of those evaluators. For example, true positive rate, false positive rate, and accuracy, and F1 score. So the way that he's logging those parameters is and getting those metrics is using the Splice binary classification evaluator. That's a library that we at Spark created to make the evaluation of your models as easy as possible. We also have a Splice multi-class classification evaluator and a regression evaluator. So any of the models you're creating can be easily tracked using our code. Once he's done running these models and is happy with what he has, he can view all of the parameters and metrics he's created in the MLflow UI. So as we saw before, this is the fraud demo experiment, and now you can see that there's a run called Ben, and again, he can name that run anything he wanted, but he chose to name it his name, and he can see all of the parameters and the metrics associated with that run for later comparison. Before he moves forward as a good data scientist, he knows that he ran this model on an undersampled and oversampled data set. So he really wants to make sure that this model is generalizable. So he pulls in the entire data set and he can run it on that whole thing. As you can see, the accuracy is very high, so he knows this model is not overfit. And because he's happy with the results he has, he can then save that model to both S3 and to MLflow itself using model.save for S3 and manager.log Spark model from MLflow. What this does is it saves the model into MLflow as an artifact, which you can then pull in later and deploy live to SageMaker. It's a really useful tool for getting those models from a development process to a live process quickly and easily. Later, a new data scientist comes into the team, Amy, and she's been tasked with this project as well. She sees Ben's work and likes his ideas, but has a few tweaks she wants to try. She thinks Ben's model took too long at 42 seconds and wants to bring that time down. In order to do that, she reduces the oversampling rate to 1.5 and switches to a logistic regression model. As we can see here, she changes the oversampling rate and logs that change, keeps the undersampling rate the same. She does the same process here, so she logs the same pre-processing commands and logs all of her features as well. When she creates that classifier as a logistic regression model, she can log that easily so she remembers exactly what she used. And she can log exactly how long that model took to take as well, right here. Again, she logs her metrics and she can go to MLflow and view the comparisons. As you can see here, her true positive rate was about 86%. And her false positive rate was really small, and she drastically decreased the time of this model. When she tests this model on unbalanced data, however, her true positive rate is not quite as high as the team was looking for. So she doesn't log her model to S3, but she is able to save it to, so she doesn't log her model to MLflow, but she is able to save it to S3 for future changes and tweaking of that model. When you look at the MLflow UI, you can see the comparison between Ben and Amy's runs. You can see all of the different metrics, including how long it took, and all the different features they used. You can also compare them side by side like this. After that model is saved to S3, the team decides to deploy Ben's model and moves on with to the next project. A few days later, more labeled data comes in. Because their models have been logged to S3, they can easily pull those in by running pipeline model.load and the S3 location of their model. They can also pull in their new data using the splice.df command and run that model very easily using model.transform on the data they received. They can again use the Splice binary classification evaluator to see how accurate their model is running on the new data. And as you can see, it's remaining at a 96% accuracy. So they're really happy with the results and they keep the model deployed for future use. Just like that, you can see how easy it is to keep track of all your data science work from start to finish. Thank you for watching, and please check out all of the things that we do at splicemachine.com.